I'd like to welcome you to our digital classroom brought to you by HD Supply. I'm Jerry Winslet along with Jason Leonard, but we'll get to him in a moment. Today's class is about NAECA III conversions and installing them in tight spaces or confined spaces. If you have any questions during the show, you can use the chat feature, which is on the right-hand side of your screen. Just type that question in there. You don't have to wait till the end of the show. We'll get to them as quick as we can. So let's go ahead and get started. The first thing we want to talk about is really what is NAECA III? Well, NAECA III is the third installment of a plan that dates back to 1987 to increase the energy efficiency of major home appliances like TVs, air conditioners, and water heaters. The NAECA energy standards have saved consumers billions in lower household energy costs. Now, NAECA III is expected to save consumers an additional $63 billion in smaller electric and gas bills. Now, these are significant savings in operating costs. The biggest impact, though, for us is the water heaters. The water heaters will simply get a couple of inches larger. And that means that the size of the space will determine what size water heater is going to fit. In the vast majority of cases, a NAECA III water heater will fit in the same space as the old water heater did. And now this is particularly true for gas water heaters, which typically have more space available. And because of where they're located, electric water heaters should fit as well. In cases where a NAECA III water heater is a little too large, we have a slightly smaller version. We have options. We have a slightly smaller version that comes with an insulating blanket. Now, this combination will help get that water heater into that tighter space. But there will be some situations, particularly with electric water heaters in a multifamily application, where that NAECA III water heater, even with a blanket, won't fit in that smaller space. If the same size NAECA III water heater won't fit, there are several approaches that we can take. Like I said, we have options. But before we start talking about all those options, I'm going to kind of step back and start talking about, NAECA III. We talked about raising the energy standards or energy efficiencies of those major home appliances like water heaters. I'm going to go over to the desk real quick. How you doing, Jason?
Doing well, Jerry. How are you?
Doing very well. So we're talking about NAECA III. We're raising the standards. Now, how do we measure energy efficiency? How are we measuring that?
Well, in terms of energy efficiency, we measure that in what's called an EF, or an energy factor. You've probably seen that number, like a .70
right,
or a .59 or whatever the case may be. That's the energy factor. Now, on its own, that number means very little all by itself, and it's because there's a lot of things that make up that number. We're talking thermal efficiency,
okay,
we're talking standby heat loss, R values, inputs, all these different things roll up into this energy factor. Now, I said that number doesn't mean a lot on its own, but if we use it as a benchmark to gauge all water heaters, now I can tell you, based on that EF, that this water heater is either more or less efficient than this water heater, as long as we're using the same standard. And that's exactly what the EF rating gives us.
Okay, so what actually changed? I mean, that's what we're talking about. I guess the EF rating went up, right?
Yeah, the EF rating did go up. If we look at the graphic here, we can kind of see how these numbers changed. Notice here's our pre-NAECA III, 30-gallon capacity. We had a threshold of a .61. Notice that now that's a .63. On the 40, we went from a 5.9 up to a 6.2. So we can kind of see where these jumps are. Notice what happens when we get down to 60, 66, 75.
Yeah.
Notice the considerable jump.
Yeah, that's a big jump. Yeah.
It is. That's important because in order to read those type of energy factors, it usually means that we're going to have to change design of the product.
Right.
We're going to have to go into like a condensing version or something like that. So once we get up into those larger capacities, NAECA III means that things change a little bit.
Okay, so I know how, let's just talk about gas right now. I know how a gas water heater works, and that standard atmospheric gas water heater. You're talking about thermal efficiency, you're talking about standby heat loss, and how much heat we're actually putting into the water is thermal efficiency. So really, we're to the point now where we're putting about as much heat as we can into a standard atmospheric gas water heater without turning into condensation. I mean, we're putting about as much as we can. So when we're talking about they get a little bit bigger and wider, I mean, the only thing we can really tackle is what? Standby heat loss?
It's standby heat loss.
Okay.
As you pointed out, we've really had as much gains in thermal efficiency as we can. And again, that's what we're talking about. how much heat from that burner actually makes it into the water. Now, on a standard gas water heater, we're talking about 40,000 BTU. What we're talking about is the input. Now, historically, atmospherically vented water heaters today are around 80% thermal efficient. That means 80% of that 40,000 BTU actually makes it into the water. That is about as much as you can squeeze out of that. That is because as you start to remove more heat from that combustion product, it's going to start to condense. We have to change the design. Things start to change after that. So really, the only place that we can get some considerable gains is really in standby heat loss. We want to control how much of that heat that we're paying to generate gets released to the atmosphere, gets released out to the pipes, that migrates into the cold water lines, those type of things.
Right.
Stop that standby heat loss. That means insulation.
Okay,
right?
so
That means we're going to have more insulation around the water heater to trap that heat in, hold it for longer periods of time.
Yeah, so that makes sense. Now the water heater is going to get a little bit larger and a little bit taller in certain situations.
It may. There's a couple of ways that we can do that. Now, we know we're talking about insulation, right? We're going to need more insulation. Now, one way we can do that, we can put that inside the jacket, right? Now, when you look at a water heater, the part that you see on the outside, of course, that's the jacket part. The actual tank is on the inside behind the insulation. Now, we can add more insulation between the jacket and the inner tank. That's why the water heater is going to get a little bit larger. We're going to add about an inch of insulation all the way around the tank. Now, because the tank's round and the insulation goes all the way around, that equates to about 2 inches in total diameter.
Now, that's inside the tank you're talking about.
That's inside the tank.
The outer jacket. Okay.
But that's not our only option to gain some extra R value.
Okay.
We don't necessarily have to put it inside the jacket. We could put it on the outside of the jacket. And we do that with what's called a blanket, an insulation blanket. If we look at the graphic here, we can kind of see what we're talking about. There's your pre-NAECA unit.
Okay.
Right? Now that unit is no longer offered anymore, right? The form factor has gone away. Our first option is just our standard NAECA option. That unit is going to be about 2 inches larger than the old unit. Now, in most cases with a gas water heater, not a problem. You usually got more than a couple inches around the water heater in most installations to put that heater in, no problem whatsoever. But if it's not, our second option we see there is the blanketed version. Now, what that gives you is now we can pretty much get back to the same form factor that we had with a pre-NAECA unit, but still get the extra R value, the extra EF raise. We're just putting that insulation on the outside of the jacket as opposed to the inside of the jacket.
Hey, that makes sense. So now, I mean, if you're in a tight location, a jacket would make sense, or a blanket would make sense, because, really when you're putting it in a tight location and you're pushing it up against the wall, there's not a lot really touching that wall. I mean, it wouldn't be all the way around the water heater. This blanket will actually compress.
It is compressible, and that's not a problem. And again, like you stated, the water heater's round. So if you push it up against a flat wall, the only thing that's going to be touching that wall is about an inch wide contact pads all the way up and down the water heater. Well, you can compress it in that spot and just allow the blanket to cover the rest of the heater, no big problem whatsoever.
Okay, so let's talk about the different dimensions that we're talking about, the different sizes. Let's go through the gas.
Yeah, let's look here and just look at the actual dimensions so you can kind of wrap your head around the numbers here. We look at our pre-NAECA model. Let's start with the 30-gallon there. Notice that the height was 61.5 inches tall. The diameter was 16. Now, the NAECA III version of that heater, 61 3/4 tall, so we really only gained about a quarter of an inch. But notice the diameter went up 2 inches.
Right.
That's that additional insulation we're talking about. Now, if you go directly below that, there's our blanketed version. Notice 61 3/4 inches on height, no change there, but notice the diameter. 16.
Right.
We're back to the original form factor that we started with, the original pre-NAECA heater. So by picking the blanketed version, you can basically get back to the same form factor.
Yeah, so that's going to make it a little bit easier. Now you have, you've got options. I mean, not only if the new NAECA water heater is a little too large, then you can always take that, the option of the blanket, which is a smaller version, plus you put the blanket on.
That's exactly right. And we see here, I know you guys, especially with multifamily, you guys may use a lot of short models, depending on headspace and that type of thing. We can kind of see here pretty much the same deal. We see a pre-NAECA 30-gallon there is 50 and 18. The NAECA version is 50 and 20, and we see the blanketed version, again, 50 and 18, back to that original form factor. So that old unit, while yes, there has been changes, as a form factor standpoint, that unit is not necessarily gone, right? We're just using it, and now we're adding the insulation blanket.
Okay, so yeah, like we said, we're having some options, and really, that's really what we really want to know about is the options that we have, especially because, you know, if you're working in a multifamily application or you're in a tight space, really, you know, since the new NECA water heater might not be the right choice, you know, what can they do besides that?
Yeah, that was the big deal. When NAECA first happened, a lot of people kind of panicked a little bit, and they go, oh, wow, water heaters are getting bigger. Especially where you guys are concerned, the type of installations that you guys are having to deal with on a daily basis, we know that the space is limited. It's hard to get into these areas. The important thing to remember is we do have options. Regardless of the installation that you're working with, we have an option that is going to work in any installation you have in front of you. We can look at the graphic and see how kind of this decision-making process plays out. There's our old unit, right? There's our original unit, 62 inches tall. This is a 40-gallon tall unit, 18 inches in diameter. Now, that unit is no longer offered. Here's our new NAECA unit. Again, same 62 inches tall, 20-inch diameter, because now we went to a 2-inch foam insulation instead of 1. And then our second option, there we go, there's the blanketed version, still 62 inches tall. Notice that the diameter back down to 18 inches. 1-inch foam cavity with the external blanket. So we're still fitting the need as far as space restraints, and we're getting the benefit of those higher EFs as well.
Yeah, so that's a great option, especially the blanket, because it is compressible. That is something that is very important.
Absolutely.
Also, you know, since we were making these changes, you know, the new NECA changes to these water heaters, we also made some product improvements, and we want to kind of go over those as well.
Yeah, well, we did. There were some changes that were made to the unit. Now, these had absolutely nothing to do with NAECA itself, but if we're going to redesign a product, now's a good time to make some of those other changes that you may want to make. If we look at the graphic here, we see one of those is minimum manifold pressures. Now, in the past, the Honeywell valve has run a 5-inch manifold. That has now dropped to 4. Depending on where you are in the country, that can be significant, particularly upper northeast, say New Jersey, even out on the West Coast, California, those type of places. Anywhere in the country where the natural gas infrastructure may be a little bit limited, may be difficult to get 5 inches manifold. Now it's at 4. So again, it's giving you more options, less likely to have a problem regardless of where you're putting it at.
Okay, I think we've got a question that came in. It says, does that mean that a higher stack on the roof, and is this only gas only?
I assume when we say we're higher stack, we're talking about basically the termination, where the metal B vent penetrates the roof. Would not change anything there as far as that concerned. All we're talking about is just the manifold pressure. The manifold pressure is going to determine our minimum inlet. Okay, there's about a 1-inch pressure drop across the valve. So if the valve has historically a 5-inch manifold, that means we need at least 6 inches water column on supply.
So now we're able to get a lower inlet pressure because it's only, if you're only looking for about an inch drop, now we're down to 4. Is that correct?
Yeah.
5 to 4. So now you're able to have a minimum of 5 or whatever it says on the valve.
Absolutely. Simply put, the water heater just operates with less gas pressure than it used to.
Yeah. And the other question is this only gas? We're starting with gas, and then we're going to get on to electric and a little bit later. So, okay, so we've made the changes on the gas valve, or on the gas pressure, went from 5 to 4 inch on the manifold pressure. We also made another change with the drain.
We did. We changed the drain valve. As you see there in the graph, you can see the old style that kind of had to come out at an angle. The new style, and you've got one right here in your hand, is now we're using a straight pass-through design.
Yes.
It's also a full ball valve. This gives you about 30% extra flow. Now, this is a cool feature to me. Having been from that world and understanding how this works on a daily basis, I can understand how important this is.
Oh, yeah.
You guys know how it is. You go to do an installation, you're tearing out another water heater, and that thing's been in 10, 12 years, and it doesn't want to drain, right? And it takes forever to drain. Well, this has about 30% extra flow, so it's going to drain a lot faster. The other benefit you get out of this, as I stated, you guys know how this works. If that water heater's been in 10, 15 years, it could be built up with a ton of sediment that may be preventing this thing from draining at all.
Right.
Yeah. Now, this straight path-through design, what this allows us to do, we can open this valve. If nothing's coming out because we're blocked up with sediment, we can actually take a screwdriver and push it through the valve and bust open any of that sediment on the other side.
Right.
Now, of course, you're going to need like maybe a cup or a pan or something, because you are going to get some water out of this before you can get up here to shut the valve off. But now you can shut the valve, hook your hose up, and drain that thing much more easily. If you've ever had to remove a 1,000-pound water heater out of an apartment and down 3 sites of flare because it would not drain, you could appreciate how much that's going to help.
And periodic maintenance on a water heater, annual maintenance is going to make that job a lot easier as well, because then you can go and flush the water heater out, because that's what helps, you know, make the water heater last longer is periodic maintenance. And one thing is to flush and drain the heater.
Absolutely.
And having that valve, you know, that's going to make that job and that process a lot faster, so you'll be able to get in and out of there quickly.
Yeah, you're flushing in that heater routinely is going to be much more productive now because we have 30% extra flow.
Exactly. All right, so now what we're going to be talking about is electric. You know, I mean, we had changes on the gas. Now exactly what we're, you know, an electric water heater is pretty efficient. I mean, you've got an electric element in water. I mean, that's what we're heating. So we can't really put any more efficiency in that way.
That's the deal. We really have, we're talking about a totally submerged heat source.
Exactly.
Right? The element is physically in the water. So you could really think of electric heating element as being 100% thermal efficient because it's totally submerged. So again, where do we get these gains? It's in standby heat loss. Again, it means more insulation. In terms of energy factor, we can look at the graphic here and see how they've changed as far as the electric product line is concerned. There again, we see the old pre-NAECA 0.93, 0.92, 0.90. Notice that for 30, 40, and 50, everything has went up to a 0.95 across the board.
Right.
The significant thing here is notice your 66, your 80s, and your 120s. Look how big of a jump.
That's a big jump.
We went from a 0.88 to a 1.98.
Yes.
That is a big jump. Now, the reason that is significant is because the only way that you're really going to achieve those type of energy factors out of an electric water heater is you're going to have to change design. You're going to have to start looking at a heat pump unit.
A different technology.
Yeah, absolutely, a different technology, because you just can't achieve those type of EFs over standard electric. So once you get up above to a 66-gallon, technology starts to change.
Okay, so now when we're talking about these electric water heaters, you know, so we're going to have to handle the heat, the standby heat loss. That means that they're going to get a little bit bigger as well, taller and wider. Let's kind of go over those dimensions and give everybody an idea.
Sure, and this is kind of the same story as before.
Well, these are the tall models.
Gas. Yeah, we see here on our graphic, there's our tall electric models. 30-gallon originally was a 46.5, 18-inch diameter. The NAECA version, still 46.5, but a 19-inch diameter, so it went up 1. We see some blanketed versions there. The significant thing, again, we talked about that 66 to 80 and the 119. Notice they're discontinued. There is no standard electric 66, 80, and 119. Notice it says C heat pump.
Yeah.
Because that's really the only way that you can get to.
It's the only way we can meet those EF ratings.
Yeah, that's the only way that you can get there.
And I know they, you know, a lot of these guys work on shorter water heaters. I mean, we've got our electric shorts as well. They've changed a little bit as well.
Yeah, there's your same deal there. And again, if we see a blanketed version, the non-blanketed version, with the blanketed version, we can get, again, close to that original form factor that we had before, and much easier installation. Yeah,
and the last thing on electric, really, on the sizes, is really what a lot of people that are watching the show work on, and that's the low boys. We're talking about you know, the shorter water heaters, the shortest water heaters that are stuck in the closet underneath an air handler.
That's exactly right.
Let's look at those heights on those.
Yeah, I mean, you guys see this every day. The water heater's in a hall closet. There's an air handler above it. There's a 40-gallon low boy slid underneath the air handler. Very, very customary installation. We see here on the model, or like our low boys, again, I'm not going to bore you with the numbers. It's pretty much the same story until we get down to that 50.
That's why I brought this up. Yeah, that 50 is what I'm looking at.
Yeah, notice that 50 low, no longer made, not only by us, but by anybody. The 50-gallon low boy has really went the way of the dinosaur.
Why?
You're not going to see the 50-gallon low anymore.
Why could it just not hit those EFs? I mean, what's the deal with that?
Well, again, we're talking about standby heat loss,
Exactly.
right? That's really the name of the game at this point, because we've made them as thermal efficient as we can get. So it's all about standby heat loss. Well, if we take a 50-gallon water heater, and everybody kind of understands in their head how tall a 50-gallon water heater is, if we shrink that down, same 50 gallons, that means it's got to get a lot wider.
Right.
Right? Now, just like us, we lose a lot of heat from the top of our head. Water heater does the exact same thing. So the larger the head space is on that water heater, the more standby heat loss, the more heat it's going to reject. That's the problem with the 50 low. It's because to get 50 gallons that short, it has to be really, really
Yeah, you got
really
more
wide.
surface area. I mean, it's gonna
Absolutely.
really radiate that
And
heat.
it's just impossible to reach those type of EFs with that large of a head space.
Okay.
So again, those 50-gallon lows are pretty much, can't get them anymore.
All right, so now, I'm in that tight location. I'm removing that old 50-gallon low boy. I'm pulling it out. I go to get a new one, and they've discontinued. I mean, that's the kind of situation what we're looking at. What's my option on that?
And that is a tough spot. And that's the question you get. You go, hey, I got a 50-gallon low in there right now, and I need to change it out. You don't offer it anymore. Nobody offers it anymore. What am I supposed to do?
Right.
Well, like we told you earlier, we do have options. One option you can do is to, instead of putting back in a 50-gallon low, go to a 40. Now, I know what you're thinking.
Yeah.
Right? I know what you're thinking. You're telling me to take a 50-gallon water heater out of my customer's home and put in a 40-gallon water heater. They're going to kill me,
Yes.
right? Well, not actually.
Right.
Because there's a way around this. If you take a thermostatic mixing valve and install it on the 40-gallon water heater, you can actually get the same amount of hot water that you did out of the 50. And that's the way around that, because we're going to mix in. We can go to the graphic here and see kind of how
Right.
this works. With a thermostatic mixing valve, we're going to bring in cold water from the source, hot water from the source, and we're going to temper those down to an outlet temperature out to the fixtures.
Right.
That's where we're going to temper it down to 120 degrees. But because we're tempering this temperature down through the thermostatic mixing valve, it no longer matters what I store the temperature at.
Right.
Without it, I have to store it at 120. So to get it to a comfortable shower temperature of, say, 107, I'm going to be using a lot of hot water.
Right.
Right? But if the thermostatic mixing valve allows me to store it much higher, say 160, I'm going to have to mix in a lot of cold to get to that magic number of 107.
Right.
That's why with a thermostatic mixing valve, you can actually get the same amount of hot water out of the 40 that you used to get out of a 50 without a mixing valve.
Yeah, because you're going to be using less hot water. So you'll turn your temperature in the tank up and then run it to a mixing valve. You're going to be able to turn the tank temperature up above 120 degrees, 140, 150 degrees, and then turn the thermostatic mixing valve down, which it will. It'll make the water heater feel bigger.
Absolutely.
And really, this doesn't just apply to electric water heaters. This applies to gas as well. And this gives us another option.
Yeah, absolutely. Again, we do have options. So regardless of what heater you have, if you want to get more hot water out of that heater, the thermostatic mixing valve is the way to go. It's actually become code in most municipalities
Right.
require that the water heater not be the only source of temperature control for the home. That means the mixing valve. And luckily, the folks down at HC Supply have you covered
Yeah.
on that.
Now that shot we were seeing, that's actually the thermostatic mixing valve. That one sits on top of the heater, correct?
Yeah, this is just one example that you can use. I kind of picked this one out because of its low profile. Again, we're talking about tight spaces. So this thing is going to install on top of the water heater. Our hot water inlet and outlets from the water heater just connect right up. We got the bypass line to temper that water down. And again, we're going to get more hot water out of this. And again, it's just a good practice, regardless whether you have electric, whether you have gas, or whether the water heater's too small or
Exactly.
not. It's just it's a great feature
And
to
for
put on
those
the water heater.
customers that are complaining about not enough hot water, I mean, this is another option. Maybe it's undersized a little bit. Being able to turn up the tank temperature, add the mixing valve, is going to make that water heater feel bigger because
Absolutely.
you're going to use less hot water.
Absolutely.
It's going to last longer. So it gives us a lot more options now.
Yeah, and again, that's what we're talking about. We're talking about options. I have this small space. Water heaters have changed. What do I have available to me to go in there? And that's exactly what we're talking about. And again, let's look back at the graphic on the electric, and we'll see how this decision process plays out.
Okay.
There's our 50-gallon tall, 54 inches tall, 20 inches in diameter. Now, historically, that had a 1.75-inch foam insulation. Now, our naked version, NAECA III version, 50 tall, 65.5 inches tall, 22 inches in diameter.
Right.
Again, we're going to a 3-inch foam cavity there. A second option, we talked about this already, the blanketed option. 16.25 inches tall, 21 inches in diameter. So again, we're getting down to almost the exact same form factor that we started.
Right.
And then our last option, just like we said, go down to a 50, install the thermostatic mixing valve. We can get the same amount of hot water we did out of the 50. Look at the form factor. We're back down to a 20-inch diameter again. So regardless of what installation you have, we have a product that will fit in that location regardless of the installation.
Yeah, it doesn't matter if it's gas or electric. You know, those thermostatic mixing valves will help, especially, you know, with the customers that are looking for a little more hot water.
That's right. That's right.
All right. So we made changes on those electrics, you know, as far as the NAECA III is concerned, but we also made some other additional changes on electric water heaters to improve them.
There were a few changes. Again, we were changing the product lineup anyway because of NAECA, so now was a good time to introduce some of these other changes. We look here on the graphic, we can see the changes that we made in terms of the elements.
Okay.
Notice that on a standard 6-year tank, 6-year part, or a 10-year tank, 6-year part, we have copper upper element. That hasn't changed, but notice the lower.
Right.
Incloy lower. That incloy element is going to last about 3 times longer than your standard copper element. And then on your 1010, your 10-year tank, 10-year part, notice that now that is dual incloy.
Okay.
So you get incloy elements top and bottom standard on your 10-year tank, 10-year part product.
And let's talk about elements for a moment. Now, you're talking about Incaloy, and actually they're low watt density Incaloys as opposed to copper high watt density elements.
They are, and you may think, well,
what are we
what does
talking
that mean
about
to me?
here? Yeah.
Right? What's the difference between high watt density and low watt density? If we can get a kind of an overhead view, we can see the difference between these two elements right here. Of course, one is, we notice that is a little bit longer than the other one. This here is a low watt density. I'm sorry, a high watt density. This is a low watt density. And what we're talking about is the surface area. How much surface area am I using to heat? Now, they're both 4,500 watt, 240 volt elements.
Right.
But because I'm spreading that heat out over a larger surface area, it means that the surface of this element itself can be a lot cooler.
Okay.
That is going to make it last longer over time. And because it's incloy, it's also less susceptible to things like sedimentation buildup and things like that. It's a lot tougher material, going to last a lot longer. Again, on average, about 3 times longer than your standard copper high watt density element.
Yeah, and that's a good thing to know, especially when it comes to if you do work on water heaters. I mean, HD Supply has kits for certain things.
Yep.
I mean, we have a repair kit that actually has Incaloy elements.
That's right. We see that right there on the graphic. There's your repair kit for your standard electric water heater. Notice that it comes with 2 Incloy low watt density elements and 2 thermostats, your upper and lower thermostat. The great thing about that kit right there is that just for a few bucks, you basically rebuilt the entire water heater. Outside of the inner tank itself, you basically have a new water heater.
There's 4 working parts on an electric water heater. There they are.
That's it.
And if you're working on them, you also need the right tool to work on those, getting those elements out. You're going to need an element socket. You know, HD Supply has that. If you take a look at there, there's the part number for that. That comes in really, really handy whenever you're doing a lot of work on electric water heaters.
Yeah, you really want one of these. If you're changing elements with any frequency whatsoever, you're going to want one of these. This one right here does fit a 1/2-inch drive or a 3/4-inch drive. 1.5 inch and 1/16 deep well socket in order to take that element out. Now they do have things like element wrenches and those type of things. Those are okay if you're changing elements maybe once a year or so, right? It's not that big a deal.
If you're doing it on a regular basis, I would go with that.
You definitely want to invest in one of these. Again, it's going to make that job a lot easier. You're going to be able to get in and get off of that job a lot faster.
All right, so here we go. We're going to put up a scenario here. All right, so you know, a lot of people that are watching this show do a lot of tight installations on electric and gas water heaters, and you know, what are some tips, especially because of the NAECA III changes? Again, let's talk about some tips that are going to help them out when they're in the field and they're faced with a situation where a water heater They barely get it out. Now they got to put in something that's even bigger, and they don't really have the room. We need some tips that are going to help us get the water heater and get the customer back in hot water, and make it easier on us. Yeah,
that's the deal. That's what this show's all about, right? We have this new NAECA III product that we know it may be a little bit larger than the old one. We know that the spaces that we're putting water heaters in, you guys see this on a daily basis. Where's the water heater at? It's in a hall closet.
Yes.
Let's look at the graphic here, and we can see, I think this is probably going to look familiar to most of you guys out there. There's a gas installation, there's an electric installation. This is pretty much what you have to work with, right?
Yeah.
This is a standard practice. Again, there's your air handler with a 40-gallon lowboy slid under it. Gas usually got a little bit more room, but you guys know how it is. Once you get out there, you get on the job, you get to the water heater, even if it's a gas, right? Even if it's one that's going to have a little bit more room. By the time you pull winter coats and Christmas trees and everything else out of the way, and you get in there to go to work, you still notice, well, there's not a lot of room here, right? There's not a lot of room. So really what it comes down to is accessibility, being able to get there and access the parts of the water heater, the plumbing lines that I need to get to. So it's really all about accessibility. Locally, our friends down at HD Supply really have you taken care about this. Anything that you can use, part related or tool related, that is going to make that job easier, again, make everything more accessible. The first thing we looked at here is where they have an installation kit for you. Notice that the hot and cold water connections are flex lines. Now, what that's going to give you is the ability to go ahead and make your initial connections with the flex line, bend those out of the way.
Yeah, you can move them around now. Yeah.
Absolutely. Just fold them out of the way. Now you slide the water heater in, bend those back over to the heater and make that one final connection. You get the same thing on the gas. There's a gas version, so if you're doing a gas install, there's everything you need to do the gas installation. Again, flexible lines. It's going to make it a lot easier to get in there.
Hold on one second, real quick before we move on. We got a question here. With a mixing valve, how much more energy to heat and maintain to 160 degrees instead of 120?
Well, in terms of the amount of BTU that we're going to have to put in, it really doesn't change because we're talking about a differential. We're talking about from a satisfaction point to a refire point. How long is it going to take me to heat it once it fires up to the satisfaction point? Well, if I raise the satisfaction point, I'm also raising the fire temperature, right? Let's say the water heater has a 15-degree differential. Means it's going to have to drop 15 degrees before it fires. So it fires up and it has to heat the water to 15 more degrees before it shuts off. Well, that moves as you change the water temperature. Now, you do get a little bit higher standby heat loss the higher you're storing the water temperature at. But again, with NAECA III, we're putting so much more insulation around that water heater. Chances are you're using hot water much more frequently than you're getting the standby heat loss.
Yeah, so the trade-off's worth it, though.
Absolutely.
I mean, you're going to get more,
totally worth
and especially when you get the satisfaction of the customer. I mean, really, if they're happy with that, the trade-off is worth it.
Yeah, but that's really the only thing. It really only comes down to a little bit higher standby heat loss because, again, you're moving that firing duration as you move the temperature. So the firing duration stays the same.
All right. So we were talking about in tight spaces on gas water heaters. Now we have, a flex gas line. That's going to help as well.
Yeah, it helps a lot. You don't have to take black malleable pipe all the way to the gas valve. Now, you're going to have black pipe coming into the closet. But by using this flex line, again, I can make that initial connection with the water heater out, make that connection, slide the water heater in, now make my final connections out here where I can get to them very easily.
Yeah, and we're typically dealing with like 40,000 BTU. We're not dealing with 199,000 where we want to have it hard piped all the way to the heater.
Yeah, and in residential, the flex lines are not a big deal at all. Today, they're widely used,
And we also, HD Supply also offers connections that are actually going to make it easier for the contractor.
Yeah, again, it's all about accessibility, like we talked about. As far as installation and hookup, it's going to be the same. But how easy it is to get in there and do what you need to do. By using things like the Shark Bike, they have the kit for you here that's got all of your fittings, your adapters, everything you need. Now you don't have to try to get the torch in there, the solder in
really
there
hard to do.
Get everything. You're reaching over. Now you can have press-on fittings with the Shark Bike. They're great. Again, widely popular today. going to make that job a lot easier.
Yeah,
Going to
it'll
be
make
easier to get in there.
a lot easier because you're not having to use the torch. You're not having to do those things. And, you know, those shark bite fittings are really, really important.
Absolutely.
All
Now,
right.
another thing you think about, we talked about maintenance earlier. We talked about draining and flushing the water heater. Changing the anode rods is a big deal when we're talking about tight spaces.
Right.
If there's an air handler directly above that water heater, it's going to be hard to change the anode rod. It's going to be hard to pull that thing out. If we're changing one out, once we get that old one out, you may have to cut it off to get it out. We put in a new one, now we can use the segmented type. And we see there we have a segmented anode rod. It's going to be a lot easier to get that thing back into the heater in that tight location. And again, all that's going to do is extend the life of that water heater.
Again, this goes with annual maintenance as well. If you're having to pull out the anode rod and you're taking a look at it and it's time to change that anode rod because it needs to, you know, that extends the life of the water heater.
Absolutely.
A segmented anode rod is actually going to help in that situation.
Absolutely.
All right, I think we have another question. It says it's talking about situational here. A situation where electric water heater in a kitchen cabinet and under a counter.
Yeah, absolutely. You see this a lot. You see it underneath they may use a portion of the kitchen cabinets to store the water heater under there. Exact same principle. It's all about accessibility. The hookups are going to be the same. That's not going to change. The difficulty is how easy for it to me to get in there. I'm not a small guy, right? So it's difficult for me to get my arms and everything else in there.
Especially when you do that. Yeah.
Well, I know, right? So anything that I can do to make it more accessible to me so that I can get in there and do what I need to do, I'm going to go that direction. And of course, HD Supply also has you hooked up with electrical test kits. This is a really great kit.
Yeah,
we put this up here for a specific reason, is because regardless of what you're working on, whether it's gas or electric, gas, you're going to check millivolts, those type of things. Electric, you're going to check the power coming to the heater. This is a great little test kit that's very inexpensive that will pretty much let you test most of the things you're ever going to want to check.
Yeah, you got a non-contact voltage tester, which is very, very handy.
Yeah, this is going to cover, you know, 75% of the things that you're going to need to check. This little kit right here has got you covered.
Yeah, and really, HD Supply has the right tools and parts for the job that you're doing. And I know you guys out there, especially, you know, you don't just do water heaters in most of the time. I mean, you may be a building maintenance where you're an apartment and you do all types of jobs, from changing doors to changing lights to water heaters. And HD Supply's got you covered on that.
Yeah, they actually do, even down to the hand tools.
Yes.
This is a kit right here that we use quite a bit around here, as you guys can imagine.
It's a mobile shop.
Yeah, it actually is. As you guys can imagine, we're snatching heaters out all the time for training purposes, put in new heaters, that type of thing. This has become kind of like our go-to bag.
Exactly.
We all kind of fight over this thing when something needs to be done. But again, they can hook you up with this kit. It really is
It's got everything
mobile
you
shop.
need, and not only just for water heaters, but for any kind of job.
Changing doorknobs, all your average maintenance things around that multifamily residence, you can take care of this, grab it in one hand, go to the job, do what you need to do, and get back out there. You guys understand how valuable your tools are and what they mean to you as to how quickly you can get this job done. The right tool is the key to everything.
Yeah, and one more tool too, and if you do a lot of work on water heaters, this is very important, especially electric water heaters. This is an amp meter. Instead of having to use this, open up the, you know, you could just wrap that around the lead wires and see if the water heater's actually working.
Yeah,
especially if you're doing a lot in a row.
Yeah, and this is a Klein Tools version, which I happen to love. I'm a big fan of Klein Tools, and we see that one there. And again, this is going to do really anything that you ever need to check electrically for the water heater. And the cool part about it is it does have a clamp-on amp meter. So most of the time, you can just walk up to the water heater, clamp this onto the service wires behind the inspection plate.
Exactly.
You know everything you need to know right there. You don't even have to dig into it.
Right. All right. Well, you know, that about covers it. Before we go, I really want to talk a little bit about if you like the PowerPoint that we had today, there's actually a downloadable version right below the viewing screen, what you're looking on our website. You know, you can look at that. Go ahead, click on that downloadable version, and keep it with you. I mean, because that's going to tell you all the part numbers that we talked about today. Plus, it's going to show you all the different heaters, changes, and options that we're providing.
And you get the video. The pre-recorded version of the video that you're watching now will be up there as well.
Yep.
So you get out on the job tomorrow, the next day, or whatever, and you go, now what was it Jerry said? Well, we're with you all the time. So all you have to do is dial us up, and we'll walk you through
that
it.
recorded version will be available on the website that you're on right now, which is university.hotwater.com/HDS.
That's right.
Just go ahead and take a look at that website too. There's other videos available on there. It's a great website. And you know, there's a lot of we've been doing this for a few months now, so I mean a couple months, about 4 months I think. And you know, all the videos that we've done in the previous months are on there, so it's a good place to go. And
great resource.
download that PDF and keep it with you so you're up to date with all the changes. But good job.
That's it.
All right. For Jason Leonard, I'm Jerry Winslet. We'll see you next time.
Be safe out there, guys.